Now, in this lecture, we will find out the length of line segment AB. In the drawing, we have a semicircle, and inside this semicircle we have three circles. The two small circles are identical, and we have also the middle circle. We know that the center of the semicircle is at point O, and the center of the middle circle is at point C, and also that the middle circle is tangent to the semicircle at this point, point O, and the second point that the middle circle is tangent to the semicircle is at this point, point X, and the straight line OX passes through the center of the middle circle through point C, that is the center of the middle circle, and we want to find out the length of this line segment AB. We also know that line segment AB is parallel to PQ, that is the diameter of the semicircle. So we will define the center of the small circle as point M. This point, we will define it as point M. And we will join together points M and C by a straight line. We will define the radius of the small circle as R, so this line segment will be equal to R. And we also know that PQ, the diameter of the semicircle, equals to 8 units, and the diameter is 2 times the radius. So if the diameter equals to PQ equals to 8 units, then the radius of this semicircle will be equal to 4 units. So PO will be equal to 4 units, and the radius OQ of the semicircle will be also equal to 4 units, and OX, it is actually both the radius of the semicircle, and it is also the diameter of the middle circle, and the diameter of the middle circle is twice as large as the radius. So if the diameter OX of the middle circle equals to 4 units, then the radius of this middle circle will be equal to 2 units. So the diameter OX of the middle circle will be equal to 2 units, and also the diameter CX of the middle circle will be equal to 2 units in its length, and Therefore, this line segment will be equal to the radius of the middle circle, that is to say it will be equal to 2 units. So actually the distance between the centers M and C of the two circles that are tangent to each other at this point will define the touching point between the two circles as point Y, and the distance between the centers of a two circle with an external lunge between them equals to the lengths of their radiuses. So the distance MC between the centers of those two circles, it is actually R, the radius of the small circle, plus 2, that is the radius of this middle circle. Okay, then we will actually the touching point or line segment PQ is tangent to this small circle at point N, and we will join together points M and N by a straight line. MN is the radius of this small circle, that is to say it equals to R, and we have a rule that states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So the tangent PQ to this small circle will be perpendicular to this radius that is drawn to the point of tangency, that is to say it is drawn to point M, that is the point of tangency of tangent PQ with this small circle. Therefore, according to the rule that I stated, the tangent PQ is perpendicular to this radius, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, PQ, the tangent PQ is tangent to the middle circle at point O. So, and we have the radius CO that is drawn to the point of tangency, that is to say it is drawn to point O, that is the point of tangency of tangent PQ with this circle, with this middle circle. So actually the radius CO of the middle circle is drawn to the point of tangency, that is to say it is drawn to point O, that is the point of tangency of tangent PQ. If this it is drawn to the point of tangency to point O, that is the point of tangency of tangent PQ with this middle circle. Therefore, the tangent PQ will be perpendicular to this radius, that is to say this angle will be equal to 90 degrees, and this angle also equals to 90 degrees. So we have here two right angles. Then from point N, that is the center of the small circle, we will go perpendicular to OC, that is to say, and we will define the touching point between the perpendicular and the radius OC as point D. So the perpendicular MD is perpendicular to OC, that is to say this angle equals to 90 degrees, and this angle also equals to 90 degrees. So we know also that PQ is parallel to AB, and we have the rule that corresponding angles between parallel lines are equal to each other. That is to say, angle P, angle NOX will be equal to this angle, that is angle AOC, and angle POX equals to 90 degrees, so angle PEX will be also equal to 90 degrees. So actually we have here quadrilateral MNOD. This quadrilateral has three right angles, 1, 2, 3, and that is to say the sum of those three right angles is 90 degrees times 3. It is 270 degrees. And we have the rule that states that the sum of the angles in any quadrilateral equals to 360 degrees. Therefore, the fourth angle must be also equal to 90 degrees. So I repeat again, in quadrilateral MNOD, we have three right angles. So 3 times 90 degrees is 270 degrees. And we know that the sum of the angles in any quadrilateral equals to 360 degrees. So 270 degrees plus the size of this angle that we will define as angle X must be equal to 360 degrees. I repeat again, the sum of the angles in quadrilateral MNOD must be equal to 360 degrees, that is to say 270 degrees plus the size of the fourth angle, that is X, must be equal to 360 degrees. Here we will subtract 270 degrees from this equality, and we will get that angle X equals to 360 degrees minus 270 degrees. So the size of angle X, it is actually 90 degrees. Okay, so the fourth angle, this angle must be equal to 360 degrees minus 270 degrees, that is 90 degrees. So in total we got the quadrilateral MNOD that has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. Okay, so we have this quadrilateral MNOD that has 4 right angles. So this quadrilateral must be at least a rectangle, if not a square. Okay, and we know that angle MN, the side MN, is the radius of this small circle, and the opposite sides of a rectangle are equal to each other. So if n equals to r, then OD will be also equal to r, and we know that OC equals to 2 units. It is the radius of the middle circle, so OC equals to 2 units. Therefore, if OC equals to 2 units, then CD will be equal to 2 units minus R. 2 units CD equals to 2 units minus R. So it is actually 2 minus R. CD equals to 2 minus R. And MC equals to R plus 2. MC equals to R plus 2. So actually, in the right triangle MCD, this right triangle, according to the Pythagoras theorem, CM square, MC square equals to CD square plus MD square. So I write it down and repeat again. In the right triangle MCD or CMD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MC square equals to CD square plus MD square. So write it down. In the right triangle MCD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MC square equals to CD square plus MD square but MC equals to R plus 2 units, so MC square will be equal to R plus 2 square and it equals to CD squared. CD equals to 2 minus R, so CD square will be equal to 2 minus R square plus MD square. So I will write it down again. In the right triangle MCD, MC square equals to CD square plus MD square MC equals to R plus 2, so MC square is R plus 2 square and it equals to 2 minus R square plus md square So here we will open the brackets on both sides of equation number 1 and we will get that r plus 2 square equals to r square plus 4r plus 4 and it equals to 2 minus r square. 2 minus r square equals to 4 plus r square minus 4r plus md square. So here we have r square in both sides of the equation, so r square will get cancelled and we have 4 on both sides of the equation, so 4 also will get cancelled. So we will add 4r to equation number 1 and we get that 4r plus 4r is 8r. 8r equals to md square. 4r equals to md square. We will take a root out of equation number 1 and we will get that md according to equation number 1 equals to the square root of 8 times r. 8 is 4 times 2, so I will write it down. It equals to the square root of 4 times 2 times r. So md equals to the square root of 4 is 2 and inside the root we have 2r. So in total we got that md equals to 2 times square root of 2r. So we write here that md equals to 2 times square root of 2r, and we know that the opposite sides of a rectangle are equal to each other, so NO will be also equals to 2 times square root of 2r. So here we will join together points M and O by a straight line. So what is the size of MO? The size of MO we know that AO is the radius of this semicircle. Therefore, AO equals to 4 units because the radius of the semicircle equals to 4 units. So AO equals to 4 units. And as you can see from the drawing, AM equals to the radius of the small semicircle, so it equals to R. So actually AO equals to 4 units. AO equals to 4 units, and MO will be equal to 4 minus R units. 4 minus R units. So we know that AO equals to 4 minus R units. MO equals to 4 minus R units. So if we focus on the right triangle M and O, this right triangle, in the right triangle M and O, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MO squared, that is the hypotenuse squared, MO squared equals to MN squared plus NO squared I will repeat again. In the right triangle M and O, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MO square equals to MN square plus NO square, and MO equals to 4 minus R, so MO square will be equal to 4 minus R square, and it will be equal to MN square. MN is the radius of this small semicircle, so MN square will be equal to R square plus NO square. NO square equals to 2 times square root of 2R square. 2 times square root of 2R square. So we will open the brackets of equation number 2 and we will get that 4 minus R square is 16 plus R square minus 8R equals to R square plus 2 times square root of 2R square is 8R. So here we have R square on both sides of equation number 2, so R square will get cancelled, and we will add R to equation number 2, and we will get that 16 equals to 16R. Here we will divide equation number 2 by R, and we will get that the radius of the small circle R equals to 1 unit. We found out that the radius of the small circle R equals to 1 unit, so here R equals to 1, and we know that the opposite sides of a rectangle are equal to each other, so OD will be equal also to R, that equals to 1, and so here we have NO. We know that NO equals to 2 times square root of 2R. 2 times square root of 2r. The opposite sides of a rectangle are equal to each other, so MD will be also equal to 2 times square root of 2r. So if we focus on triangles, the right triangle, triangle C, here it will be E, C, E, Y. We will focus on the right triangle, triangle C, E, Y. And also on the right triangle, triangle CDM. Okay, we will focus on those two right triangles, and we will prove that those two right triangles are similar to each other. So we will focus on triangle CEY and triangle CDM. So first of all, we have the two right angles are equal to each other, that is to say angle CEY, this angle is equal to angle CDM, this angle, and they are both right angles, they are equal to 90 degrees. Okay, I will repeat again, angle CEY equals to angle CDM, and they are both angles are right angles, they are equal to 90 degrees. And we also have a common angle. This angle, angle C, is a common angle, it belongs to both triangles, so angle C equals to angle C. It's a common angle that belongs to both triangles. And the third angle, angle CYE, in triangle CY equals to angle CMD in triangle CDM, and those two angles are equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem states that if we have two angles in one triangle that congruent to two angles in another triangle, then the third pair of angles must also congruent. Okay? So we actually proved that all three angles in triangle CEY, 1, 2, 3, are congruent to all three angles of triangle CDM, 1, 2, 3. So we actually proved that triangle CDM is congruent to triangle CEY according to angle similarity rule. I'll repeat again. We actually proved that triangle CDM is similar to triangle CEY according to angle similarity rule. So from the fact that triangle CEY is similar to triangle CDM, we will conclude that CE over CY equals to CD over CM. I'll repeat again. From the fact that triangle CEY is similar to triangle CDM, we will conclude that CE over CY equals to CD over CM. Okay, so actually CE over CY equals to 2, and it equals to CD equals to 2 minus R over CM equals to 2 plus R. So in total we got that CE over 2 equals to 2 minus R over 2 plus R. We have already found out that R equals to 1, so we put the value of 1 inside R, and we will get that CE over 2 equals to 2 minus 1 is 1 and 2 plus 1 is 3, or CE according to equation number 2 equals to 2/3. So we found out that CE equals to 2/3, CE equals to 2/3, and what is the value of CD? The value of CD, it is actually CD equals to 2 minus R, therefore CD equals to 1 unit, CD equals to 1 unit, and the value of ED is CD minus CE, that is to say it equals to 1 minus 2/3, so ED equals to 1/3, it equals to 1 over 3. So in total the value of OE, on the drawing you can see that the value of OE, it is actually the value of line segment OE equals to 1 plus ED. I'll repeat again, the value of OE, it is actually equals to OD, that is R, plus DE. That is to say the value of OE equals to R, that is 1, plus ED, that is 1/3. So in total we got that the value of OE equals to 4 over 3 units. So OE equals to 3 over 4 units. We will join together points O and B by a straight line. OB is the radius of the semicircle, therefore it equals to 4 units. And we have the rule that states that the corresponding angles between parallel lines are equal to each other. AB is parallel to PQ, so those two angles are equal to each other, so we know that this angle equals to 90 degrees, so this angle will be also equal to 90 degrees. And according to the rule that the sum of the angles on one side of a straight line equals to 180 degrees, so the sum of the angles at point E, at one side of point E, must be equal to 180 degrees, and this angle equals to 90 degrees, so this angle must be also equal to 90 degrees in order to complete the sum of the angles to 180 degrees. So therefore triangle OEB is a right angle because it has one angle that equals to 90 degrees. Triangle OEB is a right triangle, and in the right triangle, triangle OEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to OE square plus EB square. I repeat again, in the right triangle, triangle OEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB squared, that is the hypotenuse square, equals to the sum of the squares of the perpendiculars, equals to OE square plus EB square. OB equals to 4 units, so OB square is 4 square. 4 square is 16. So 16 equals to OE square. OE equals to 4 over 3. So OE square equals to 4 over 3 square plus EB square. So we learned that 16 equals to 4 over 3 square plus EB square. 4 over 3 square is 16 over 9, so I write it down. We got that 16 equals to 16 over 9 plus EB squared. Here we will subtract 16 over 9 from equation number 4, and we will get that according to equation number 4, 16 minus 16 over 9 equals to EB squared. Okay. Sixteen minus 16 over 9 equals to EB squared. Here we will multiply 16 by 9 and then we will divide it by 9 in order to have a common factor with 16 over 9, and we will get that 16 times 9 over 9 minus 16 equals to EB squared. 16 times 9 minus 16 is 16 times 8 over 9 equals to EB squared. 16 is 2 times 8, so we write it down. So 8 times 8 times 2 over 9 equals to EB squared, according to equation number 4. Here we take a root out of equation number 4, and we will get that EB equals to the square root of EB equals to the square root of 8 times 8 times 2 over 9 . So we took a root out of equation number 4 and we got that EB equals to the square root of 8 times 8 times 2 over 9. We know that the square root of 9 is 3 and the square root of 8 times 8 is 8. So in total we will get that EB equals to 8 over 3 times square root of 2. So we found out that EB equals to 8 over 3 times square root of 2 units. EB equals to 8 over 3 times square root of 2 units. So here we will prove that those two right angles can go into each other. The triangle OEB, the right triangle OEB is congruent to the right triangle AEB. So we will focus on the two green right angles, triangle OEB and the right green triangle, triangle OEA. Okay, we'll focus on the two right triangles, right green triangles, triangle OEB and triangle OEA. First of all, we know that OB equals to OA equals to 4 units. OB equals to OA equals to 4 units. It is the radius, both of them are radiuses of the semicircle that are equal to 4 units. Radiuses of the semicircle . I will repeat again. OB equals to OA equals to 4 units. Both of those two sides are the radiuses of the semicircle that equals to 4 units. And we also have a common side. Side OE is a common side, it belongs to both triangles. OE equals to OE. It's a common side that belongs to both triangles. I will repeat again. OE equals to OE is a common side that belongs to both triangles. So actually, we proved that the two green triangles are congruent to each other We actually proved the triangle OEB is congruent to triangle OEA according to the rule that says that if the hypotenuse and a perpendicular are congruent in two right triangles, then the triangles are congruent to each other. I repeat again, triangle OEB is congruent to triangle OEA. The two right triangles congruent to each other according to the rule that if the hypotenuse and the perpendicular are congruent in two right triangles, then the triangles are congruent to each other. So from the fact that the two right triangles congruent to each other, we will conclude that AE equals to EB. AE, side AE of triangle OEA equals to side EB of triangle OEB according to the rule that corresponding angles in congruent triangles are equal to each other. Again, side AE equals to side EB according to the rule that corresponding sides in congruent triangles are equal to each other. Okay, and what is the value of AB? From the drawing, you can see that AB equals to AE plus EB. I repeat again, AB equals to AE plus EB, but we know that AE equals to EB, therefore AE plus EB will be equal to EB plus EB. Okay, EB plus EB. So AB equals to 2 times EB. AB equals to 2 times EB. I repeat again, AB equals to 2 times EB. And what is the value of EB? We have already found out that EB equals to 8 over 3 times square root of 2. Okay, EB equals to 8 over 3 times square root of 2. So it is actually 2 times 8 over 3 times square root of 2. AB equals to 16 over 3 times square root of 2 units. That is also equals to 5 times, it equals to 5 times 5 point square root of 47. Square root of 2 times 16 over 3 equals to 7.54 units. Okay, so we actually found out that the value of line segment OB equals to either 16 over 3 times square root of 2 units, or it equals to 7.54 units. I will repeat again, the value of the length of line segment AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the value of line segment OB of the length of line segment AB equals to 7.53 units. Here, the value of line segment AB, it is actually equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the length of AB equals to 7.54 units. So now I'll summarize the lecture. Actually, we wanted to find out the value of line segment AB, and we have here a semicircle, and inside this semicircle we have 3 circles. The 2 small circles are identical, and the middle circle, the center of this middle circle is at point C, and the middle circle is tangent to the semicircle at point O, that is the center of the semicircle itself also, and also at point X. And OX, it is both the radius of the semicircle, and it is also the diameter of the middle semicircle, of this semicircle. So if the diameter PQ equals to 8 units, then the radius of the semicircle will be equal to 4 units, because the diameter is twice as large as the radius. So if the diameter is 8 units, then the radius of the semicircle will be equal to 4 units. And here we know that the diameter of the middle circle equals to 4 units, therefore the radius will be equal to half of it. That is to say, the radius of the middle circle will be equal to 2 units. And here we have, I draw the quadrilateral MNCO again here. Actually, MC is the distance between the two centers of the two circles, and when you have an external point between two circles, then the distance between their centers will be equal to the sum of the radiuses. That is to say, it will be equal to 2 plus r, because the radius of the middle circle is 2 units and the radius of the small circle is r. So 2 plus r is the distance between the two centers, that is to say MC equals to 2 plus r. And actually here Mn is the radius of the small circle. Mn is the radius of the small circle, and we know that the radius is perpendicular to its tangent, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees, because the radius CO is perpendicular to the tangent PQ, and we draw perpendicular from point M to OC, that is to say this angle equals to 90 degrees and this angle equals to 90 degrees. So if you focus on MNOD, we have here 3 right angles, and the sum of 3 right angles is 90 times 3 is 270 degrees, and we know that the sum of the angles in any quadrilateral equals to 360 degrees, therefore 270 degrees plus the size of the fourth angle must be equal to 360 degrees. So 270 degrees plus x equals to 360 degrees. So we subtracted 270 degrees from this equality and we got that this angle equals to 90 degrees. Therefore, actually, quadrilateral MNOD has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, if not a square. So quadrilateral MNOD must be at least a square, must be at least a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say MN equals to OD, and if MN equals to R, then OD must be also equal to R, because the opposite sides of a rectangle are equal to each other. Okay, so here in triangle MCO, in the right triangle MCO, according to the Pythagoras theorem, MC square equals to CD square plus MD square. MC equals to R plus 2, CD equals to 2 minus R, and MD is the missing variable, so we open the brackets here. R plus 2 square equals to R square plus 4R plus 4, and 2 minus R square equals to 4 plus R square minus 4R plus MD square. So here R square will get cancelled because we have R square in both sides of the equation, number 1, and 4 will also get cancelled because we have 4 on both sides of the equation. So in total we got that 4R plus 4R, 8R equals to MD square. Here we took a root out of equation number 1 and we got that MD equals to the square root of 8R, that is to say MD equals to square root of 4 times 2 times R. On MD, the square root of 4 is 2, so we got that MD equals to 2 times square root of 2R. Okay, so here we found out that MD equals to 2 times square root of 2r, and the opposite sides of a rectangle are equal to each other, so MD equals to NO, and because of the fact that MD equals to 2 times square root of 2r, then NO will be also equal to 2 times square root of 2r. Okay? Then we know that OA is the radius of the semicircle, and OA, therefore OA equals to 4 units. And what is the size of MO? The size of MO, it is actually the radius of the semicircle minus the radius of the small circle. So OA equals to 4 minus R. So in the right triangle MNO, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, MO square equals to MN square plus NO square. But MO equals to 4 minus R, so MO square equals to 4 minus R square equals to MN square. MN equals to R, so MN square will be equal to R square plus NO square. We have already found out that NO equals to 2 times square root of 2R, so NO square will be equal to 2 times square root of 2R squared. We open the brackets in this equation number 2, and we got that 4 minus R square equals to 16 plus R square minus 8R, and this plus R square plus the square root of this 2 times square root of 2R equals to 8R. So we have here R square in both sides of the equation, so R square will get cancelled. And here we have, we added 8R to this equation number 2, and we got that 16 equals to 16R. We divided equation number 2 by 16, and we got that the radius of the small circle equals to 1 unit. The radius of the small circle equals to 1 unit. Then we actually proved that triangles, the right triangle, triangle CEY, is similar to the right triangle, triangle CDM. Why? Because they have 2 right angles, therefore the 2 right angles of course are equal to each other. Angle CEY equals to angle CDM equals to 90 degrees. Angle C equals to angle C. It is a common angle that belongs to both triangles. So angle C equals to angle C is a common angle that belongs to both triangles. And the third angle, angle CYE equals to angle CMD. According to third angle theorem, the third angle theorem states that if you have 2 angles in one triangle that congruent to 2 angles in another triangle, then the third pair of angles must also congruent. So therefore angle CYE equals to angle CMD according to third angle theorem. So we actually proved that all 3 angles of the right triangle CEY congruent to all 3 angles of the right triangle, triangle CDM. Therefore we proved that triangle CDM is similar to triangle CEY according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that if you prove that all 3 angles in one triangle congruent to all 3 angles in another triangle, then you prove that those 2 triangles are similar to each other according to angle similarity rule. So from the fact that triangle CY is similar to triangle CDM, we will conclude that CE over CY in triangle CY equals to CD over CM in triangle CDM. So CE over CY. CY equals to 2 units. This is the radius of the middle circle. CD equals to 2 minus R, and CM equals to 2 plus R. So in total we got that CE over 2 equals to 2 minus R over 2R. Okay, and we have already found out that R equals to 1. So CE over 2 equals to 2 minus R is 1, 2 minus 1 is 2, and 2 plus R is 1, so 2 plus 1 is 3. So in total we got that C over 2 equals to 1 over 3. Here we multiply the equation number 2 by 2, and we got that CE equals to 2 over 3 units. Line segment CE equals to 2 over 3 units. Then we know that DE OE equals to R plus DE. I'm repeating again. OE equals to R plus DE. So OE equals to R is 1 and DE is third. So OE equals to 1 plus third. 1 plus third is 4 over 3 units. So we found out that OE equals to 4 over 3 units. Then we join points O and A together. We all join points O and B together by a straight line. And the triangle OEB is a right angle. Therefore, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to OE square plus EB square. OB is the radius of the semicircle. It equals to 4 units. So OB square is 4 square. 4 square is 16. OE equals to 4 over 3 units. So OE square is 4 over 3 square equals plus EB square. So 16 equals to 4 over 3 square is 16 over 9 and plus EB square. So 16 equals to 16 over 9 plus EB square. Here we subtracted from this equation number 4 16 over 9, and we got that EB equals to 16 minus 16 over 9, or EB square equals to 16 minus 16 over 9 square. And here we multiplied 16 by 9 and then we divided by 9 in order to have a common factor with 16 over 9. And we got that 16 times 9 minus 16 over 9 equals to EB square. 16 times 9 minus 16 is 16 times 8 over 9 equals to EB square. We know that 16 equals to 2 times 8. So we have 2 times 8 times 8 over 9 equals to EB square. Here we took a root from this equation number 4, and we got that EB equals to the square root of 8 times 8 times 2 over 9. The square root of 8 times 8 is 8, and the square root of 9 is 3. So in total we got that EB equals to 8 over 9 times square root of 2. Again, EB equals to 8 over 3 times square root of 2. Okay, the square root of 8 times 8 is 8, and the square root of 9 is 3. So in total we got that EB equals to 8 over 3 times square root of 2 units. Then we proved that triangle OEB is congruent to triangle OEA. Actually, they are both right triangles. So angle side OB equals to side OA equals to 4 units. They are both the radiuses of the semicircle that equals to 4 units. OE equals to OE, it is a common side that belongs to both triangles. Therefore, we proved that the right triangle OEB is congruent to the right angle OEA, according to the rule that if you have two right angles and you prove that the hypotenuse and the perpendicular in the two right angles congruent to each other, then you actually proved that those two triangles congruent to each other, because when we are talking about right triangles, it is enough to prove that the hypotenuse and one perpendicular are congruent in both triangles, and in this way you actually prove that those two right angles congruent to each other. Okay, and because of the fact that we proved that the hypotenuse OB equals to OA equals to 4 units, this is the hypotenuse that are equal in both triangles, and OE equals to OE. This is the perpendicular that equals in both triangles. We actually proved that those two triangles, the triangle OEB is congruent to triangle OEA. And because of the fact that those two triangles congruent to each other, we will conclude that AE equals to EB, according to the rule that corresponding angles in congruent triangles are equal to each other. Triangle OEA is congruent to triangle OEB, therefore the corresponding sides AE and EB will be equal to each other, according to the rule that corresponding sides in congruent triangles are equal to each other, therefore AE equals to EB. Okay, so AB, what is the value of AB? AB equals to AE plus EB. So you can see from the drawing, AB equals to AE plus EB. AB equals to AE plus EB. But we know that AE equals to EB, so we can substitute AE by EB, because AE equals to EB. And we will get that AB equals to AE plus EB, and we will substitute AE by EB, and we will get that AB equals to EB plus EB, or AB equals to 2 times EB. So AB equals to 2 times EB, and we've already found out that EB equals to 8 over 3 times square root of 2 units. So 2 times 8 over 3 times square root of 2 units, it is 16 over 3 times square root of 2 units. So the length of line segment AB equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the length of line segment AB equals to 7.54 units. I will repeat again. The length of line segment AB, this line segment, equals to either 16 over 3 times square root of 2 units, or in terms of numbers, the length of this line segment AB equals to 7.54 units. Okay, thank you very much.